mutually exclusive events. So two events A and B are said to be two events A and B are said to be mutually exclusive if the set corresponding to if set corresponding to events A and B are disjoint. That is nothing but if A intersection B, which is equals to phi, so two events are A and B are said to be mutually exclusive if the set corresponding to the event A and B are disjoint. That is nothing but if A intersection B equals to what? We have phi, then we can say it is mutually exclusive event. In other words, both event A and B cannot occur simultaneously. So in other words, we can say, in other words, both event A and B cannot occur simultaneously, right? For example, let's see. In throwing a die, we have a sample space. It is denoted by S. That is 1, 2, 3, 4, 5, 6. So if we designate the event A equals to 3 and event B equals to 5, then A and B are what? Mutually exclusive. As the die cannot fall with its 3 and 5 dots uppermost simultaneously, right? So we cannot get a die at a time uppermost 3 as well as 5. So 3 and 5 are what here? They are mutually exclusive. Got it? So next one, exhaustive event. Exhaustive event. So let's see, exhaustive event. Two events A and B are said to be exhaustive if the union of the set corresponding to event A and B is the sample space. Yes, that is nothing but if A union B equals to what? Yes, which is nothing but our exhaustive event. In other words, we can say either of the event A, either of event A or B occurs in any trial or experiment. In any trial or experiment. In general, we can say if A1, A2, so on, An or n events of a sample space S, sample space S, and if A1 union A, union A3, so on up to An, we can write union I equals to 1 to n, A which is equals to S. So it is in general, we can write here exhaustive means A union B equals to S. In general, you can take n events or n sample space S, then A1 union, A2 union, A3, so on up to n, we can write it as union I equals to 1 to n A, which is equals to the sample space S, which is nothing but our exhaustive event. So the next heading is mutually exclusive and exhaustive event. Mutually exclusive and exhaustive event. So let's see. Two events A and B are said to be two events A and B are said to be mutually exclusive and exhaustive mutually exclusive and exhaustive if sets corresponding to A and B are such that they are disjoint and their union is the sample space. Yes, right? That is, if A intersection B equals to phi and A union B equals to yes, which is nothing but already we know A intersection B equals to phi, it is mutually exclusive, and A union B, which is equals to exhaustive event. So two events A and B are said to be mutually exclusive and exhaustive if sets corresponding to A and B are such that they are disjoint, means this one, and their union is a sample space. Yes, this one, right? So it is mutually exclusive and exhaustive event. So in general, already you know, even it is so on up to n are the events of a sample space. Yes. So if I intersection aj equals to phi for I is not equals to j. For example, let's see, in tossing a coin, getting head or tail are two mutually exclusive and exhaustive events. So tossing a coin, getting head or tail are two mutually exclusive or exhaustive events. So here mutually exclusive means what we have, A intersection B equals to phi. So tossing a coin, getting head or tail. Head or tail, if you take event A, get head, event B, get tail. Head or tail. So what do we get here? HE intersection T is equals to phi only. So similarly in throwing a die, getting an even dots or odd dots uppermost are two mutually exclusive and exhaustive event only, right? So this is nothing but mutually exclusive and exhaustive example. So next class we can see axiomatic approach to probability.